What does the letter delta signify in IR spectroscopy, and how does it correspond to deformation vibrations? How are deformation vibrations further classified, and what is the distinction between in-plane and out-of-plane deformation vibrations? How do in-plane deformation vibrations differ from out-of-plane deformation vibrations in terms of molecular movement and bond angles? What does the term in-plane deformation vibration refer to, and how is it represented in the IR spectrum? What are the specific types of in-plane deformation vibrations, such as in-plane wobble, rho, and shear wobble, delta S, and how do these movements affect the molecule's structure? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? What is meant by out-of-plane deformation vibration, and how is it represented in the IR spectrum? How are out-of-plane deformation vibrations subdivided into out-of-plane wobble, omega, and twist vibration, tau? And how do these different types of vibrations impact the molecule? How does understanding the different types of molecular vibrations, such as telescopic and deformation vibrations, help in analyzing the IR spectrum and identifying molecular structures? How does the ability to differentiate between asymmetric and symmetric telescopic vibrations contribute to the interpretation of IR spectra? How do the various forms of deformation vibrations, including in-plane and out-of-plane variations, provide insights into the molecular dynamics of the material being studied? What are the typical coordinates used in an IR spectrogram to represent the absorbed light, and how are the horizontal and vertical coordinates defined in terms of wavelength and transmittance? How is wavelength lambda measured in the IR spectrogram, and in what units is it typically represented, such as micrometers μm? How does the wave number 1/lambda cm-1 relate to the wavelength in the IR spectrum, and why is it often used as an alternative to wavelength for displaying the absorbed light bands? How is the percentage transmittance T% defined in an IR spectrogram, and what does it represent in terms of radiant light passing through the sample? What is the mathematical expression used to calculate the percentage transmittance, and what do the variables I and I0 represent in this equation? How is the transmitted intensity I related to the incident intensity I0, and how does this affect the calculation of transmittance? What does the percentage transmittance value indicate about the amount of light that passes through the sample, and why is this a crucial piece of information in IR spectroscopy? How does the use of percentage transmittance allow for understanding the absorption characteristics of the sample material, and what role does this play in interpreting the IR spectrum?